AP Chemistry Problem number 11. Account for each of the following observations in terms of atomic theory and/or quantum theory. Explain with as much detail as possible. Part A, atomic size decreases from Na to Cl in the periodic table. So across the periodic table from Na to Cl, the number of electrons and the number of protons in the nucleus increase. This results in an increased nuclear charge, so the greater attraction for the electrons draws them in closer and pulls the electrons tighter together. And so this makes the atomic size smaller as we move across the periodic table, which is why atomic size decreases from Na to Cl. Part B, the first ionization energy of K is less than that of Na. So ionization energy is the ability to remove an electron. As you go down the periodic table, ionization energy decreases. So this is because of shielding. Na and K both have one valence shell electron in its respective s orbital. So the electron configuration for Na is Ne3s1, while K is Ar4s1. So because of that, we can tell that K is farther away and it's down the periodic table, so that's a way to note that. And so the K atom's valence electron is farther away from the nucleus than the Na atom's valence electron. So the greater the distance, the less attraction there is to the nucleus because of the addition of an orbital. So it is harder to remove an electron for K than it is for Na. And so the valence electron is less attracted to its nucleus, and so the K atom has a lower ionization energy because it is easier to remove the electron from the K atom rather than the Na, since there are less orbitals in it, and the K atom has its valence electrons closer to its nucleus. C. Each element displays a unique gas phase emission spectrum. So each element has a unique set of quantized energy states per its electrons because it has a unique nuclear charge and a unique electron configuration as well. So as an electrons of an element absorbed quanta of an energy, they change to a higher, more excited energy state. So during this process, energy is released as EM radiation as the electrons cascade to a lower energy state. So each proton of the EM radiation is associated with a specific wavelength, a flux of which produces the lines of the emission spectrum. Part D, the Ca2 plus and Cl minus ions are isoelectronic, which means they have the same number of electrons, but their radii are not the same. Which ion is the larger radius? Explain. So Cl minus is going to have a larger ionic radius than Ca2 plus because there is an increase in nuclear charge. To further explain, like said in the question, they are isoelectronic, which means they both have the same number of electrons, which is 18. However, they do have a different number of protons. Calcium has 20 protons, while chlorine has 17 protons. So the more protons you have, the greater the pull is and the attraction is of the electrons to the nucleus. And so because calcium has more protons than chlorine, while they do have the same number of electrons, the valence electrons in calcium have a stronger attraction to the nucleus, which means the electrons are pulled in closer together, and chlorine has a smaller attraction because of the smaller nuclear charge, and so that would explain why Cl minus would have the largest radius of those two. Part E, compounds containing Kr have been synthesized, but there are no known compounds of that contain He. So helium has a filled shell, which is 1s2, and so it doesn't really lose or gain electrons, kind of like noble gases, how they fit its octet rule and have 8 valence electrons, and so it doesn't really gain or lose electrons. Since this is the first shell, it only has 2 that it needs to fill, and so therefore helium does not react. Krypton, however, has a field for s and for p, but it doesn't have a field for the orbital. In fact, it's empty. So because of the empty orbital, it affects krypton's reactivity.